Hi guys, welcome to your very last video. Nice job, you have made it. Thank you to all of you who have hung in there. I know videos are not the ideal way to learn. Believe me, I wish we were doing it differently. Don't forget to email me if you have any questions. I know that says use your Heron email. I'm so sorry, I forgot to change that. That should say use your Riverside email. The quarter ends Friday. If you are happy with your grade, you have a 70% or higher, you are done. If not, you can use next week to get everything turned in. Even if you have like a B plus and you're still trying to shoot for that A, you can turn in all the late work that you want. Your bonus point project is due Friday at midnight, and you need to submit via the Google form. Struggles and celebrations. Celebrations are that you made it, and I'm going to give you the code word right now. The code word for today is summer. It's almost here. Even if you're doing Summer Academy, we've really been working hard to switch some things up, so I hope that you'll find Summer Academy a little easier to deal with than this was. I know this has been a difficult time for everyone. We're doing the best we can, and we appreciate that most of you are as well. All right, this is the culmination of the quadratics unit. This lesson is not meant to reteach you all of quadratics. It's just meant to do some review. So if you're still struggling with solving or graphing quadratics, go back and review any of those old videos. All right, history of quadratics. The ancient Egyptians and Babylonians were the first civilizations to explore the idea of quadratics. Their investigations mostly centered on the maximization of the area of rectangular buildings and plots of land. So they wanted to make the space as big as possible. Symbolic algebra wasn't invented until much easier, so they used geometric modeling to solve these problems. All right, a teacher named Mrs. Hoffman is going to start a quarantine garden. She got 52 feet of planking to build a raised bed. What is the largest area garden that she can build? All right, so the only thing we really know about this is that we have 52 feet of planking. So the only thing we really know about this is that we have 52 feet of planking. So I know that all the sides added together, the perimeter, which is the length plus the width plus the length plus the width, has to be 52. Let's simplify this a little bit. We have two lengths and we have two widths, and that's equal to 52. Now, I want to maximize the area. I want to make the area as big as possible. So I'm going to use a system of equations to simplify this a little bit so that I don't have to deal with two variables in my equation. So I want to make this, let's see, I'm going to solve for L, let's say. So we'll subtract 2W from each side. So 2L equals 52 minus 2W. We're going to divide everything by 2. So the length is equal to 26 minus W. So in this other equation, I'm going to replace the length with 26 minus W, and then I'm just going to distribute. So I get negative W squared plus 26W has to equal the area. Well, if you remember last time we learned that when we see words like maximize, we're talking about the vertex. Largest is the same thing as talking about the vertex. We want the largest area, which is the highest amount. So I want to write my vertex formula, which is usually x equals negative b over 2a. Well, I'm not using x, I'm using w. So I can do negative 26 over 2 times negative 1, because this is my a, this is my b, c would be 0. This becomes negative 26 over negative 2, and so the largest width that we can have is 13. To find the length, we're just going to substitute back into either one of these equations, but I'm going to use my perimeter here, the 2L plus 2W equals 52. So I now know that the width has to be 13 to make this the largest area possible. We have 2L plus 26 equals 52, minus 26 from each side, so 2L equals 26. Divide both sides by 2, so the length could also be 13. So in order to get the largest area possible with 52 feet of planking, she needs to build a bed that's 13 by 13. All right, I want you to pause the video. Using that same example, I want you to try this one on your own. All right, welcome back. You should have remembered that we have a length and a width. And the only thing we know right now is that I have 44 inches of cardboard. So that's 2 times the length plus 2 times the width equals 44. I'm going to solve for the length, but you could have solved for the width. You'll get the same thing. So that's 44 minus 2W equals 2L. I'm going to divide both sides by 2 to get L alone. So that's 22 minus W equals the length. So I'm trying to maximize the area. So let's get our formula for area. Area is length times width, but I now know that length can be written as 22 minus W. I'm going to distribute, so that becomes 22W minus W squared. And so let's rewrite this in the right order. That's negative 1W squared plus 22W plus 0 is my quadratic equation there. Largest should make us think of maximum, which should make us think of the vertex, which is usually negative b over 2a. But I'm going to use that the width is negative 22 over 2 times negative 1. So that's negative 22 over negative 2, which is 11. And then if I put that back into my perimeter formula, the perimeter was 44. We don't know the length yet. We know the width is 11. So that's 44 equals 2L plus 22. Subtract 22 from each side, so 22 equals 2L. Divide both sides by 2. So we want to have a ceramic tile that is 11 by 11. All right, sometimes we need to make things a little bit bigger. We've got a garden that's measuring 12 by 16. So currently the garden is 12 by 16, that small space on the inside. But we're going to install a pedestrian pathway all around it. So that's what this space is on the outside, this pedestrian pathway that we're going to add on. That's going to increase our total area to 285 square meters. What will be the width of the pathway? Okay, so we can't use 16 by 12 to make the area, but because I'm adding something to each side. This is 16 plus some amount. 2 of them make this whole space. So this is 16 plus 2x. We can do the same thing for the other side. This is 12 plus 2x. And that is increasing our total area to 285 square meters. So it's going to be 2x plus 12 and 2x plus 16 multiplied together to give 285. Well, this is definitely not standard form, and I can't solve an equation that's not in standard form. So I'm going to distribute. I need to do 2x times 2x plus 16, and I need to do 12 times 2x plus 16. And that equals 285. That becomes 4x squared plus 32x plus 24x plus 32 equals 285. This becomes 4x squared. Excuse me, that should have an x on it. Sorry about that. 4x squared plus 56x plus 32 equals 285. And then I need this to be equal to 0, so I'm going to subtract 285 from each side. So that's 4x squared plus 56x. We're going to do 32 minus 285. And that's negative 253 equals 0. I definitely don't know how to factor that. Those numbers are too big for me to figure out. So I'm going to use quadratic formula. We're not finding the maximum area or anything, which is why we're not using our vertex. We actually want to know what the lengths are, which is why I'm solving for x. So this is going to be negative b plus or minus the square root of b squared. So 56 times 56 is 3,136. Plus negative 4. Negative 4 is always in the problem. Times a times c all over 2 times a. Simplify what's inside our radical first. So this is 3,136. Negative 4 times negative 253 is 4,048 over 8. And then that's negative 56 plus or minus the square root. I'm going to add 4,048 to 3,136. And we get 7,184 divided by 8. I'm going to do the square root of 7,184, and I get 84.8. So that's negative 56 plus or minus 84.8 divided by 8. This is going to become negative 56 plus 84.8 divided by 8. and negative 56 minus 84.8 divided by 8. I'm going to solve these two problems. Negative 56 plus 84.8. Hit enter and divide that by 8, and I get 3.6. Negative 56 minus 84.8 divided by 8 gives me a negative number, so I'm going to throw that one out. We're not going to use that one. All right, I haven't actually answered my question. It says, what will be the width of the pathway? Well, let's see. We've got the length of the pathway here and the width of the pathway here. Oh, the pathway, not the whole thing, sorry. All we really need to find out is what x is equal to, which is this. It's 3.6. We are done there. Sorry about that. Nice job. All right, I want you to pause the video and try this one on your own using the same steps we just did. All right, so you're wanting to mat an 8x10 picture for framing. If you didn't know, the mat is that little white thing that goes around the outside edge of pictures in a frame. And so we're going to add on an amount to each side. So from here to here is no longer 10, it's 10 plus 2 x's. And from here to here is no longer 8, it's 8 plus 2 x's. And I'm going to switch those around when I do my problem and do 2x plus 8 or 2x plus 10. So now I'm going to do my area, 2x plus 10 times 2x plus 8 equals 168. I'm going to multiply these together, so that becomes 4x squared plus 16x plus 20x plus 80 equals 168. This becomes 4x squared plus 36 plus 80 equals 168. And I need this to be in standard form, so I'm going to subtract 168 from each side. So it's 4x squared plus 36x. I'm going to do 80 minus 68. Sorry, minus 168. And I get negative 88 equals 0. Again, I'm not even going to try to factor. I'm going to jump straight to the quadratic formula. So that's going to be negative 36 plus or minus the square root of b squared. So that's 36 times 36, which is 1,296 plus negative 4 times a times c, all over 2 times a. So now we have negative 36 plus or minus the square root of 1,296 plus negative 4 times 4 times negative 88 is 1,408 all over 8. This becomes negative 36 plus or minus the square root. I'm going to add those two numbers together, and I get 2,704 divided by 8. I'm going to find the square root of 2,704, and I get 52. So this would have been factorable, but it's okay that we didn't. I'm going to split this up into two problems, negative 36 plus 52 divided by 8, and negative 36 minus 52 divided by 8. This one's going to give me a negative because it's going to turn into a negative divided by a positive. So I'm just going to solve this one, negative 36 plus 52, hit enter, and divide by 8, which is 2. So the mat is 2 inches wide because x equals 2. All right, now's the time you're going to go back to your haiku and complete the More Applications of Quadratics IP. You can use this video, your notes, or office hours for help. Make sure you email me with questions. This one's a little bit different, so don't be afraid to reach out if you're having some trouble. Don't forget the bonus project is due Friday at midnight, and I'm actually going to extend that. If you want to turn that in next week, I will still grade it. So that's a little reward to those of you who have been keeping up. If you want to turn it in next week, I will definitely still grade it. But the policy for the whole school is everything has to be turned in by Friday the 29th. I cannot take anything after that. Reach out if you have any questions. Love all of you. Hope you have a great summer. Miss you so much.